All right. Here's the video on 8.3 trig integrals, specifically integrals that deal with sine and cosine. We'll look at integrals that deal with secant and tangent another day. So, daily problem, integrate integral e to the 2x sine of x dx by integration by parts, and specifically pick u to be sine of x, only because your book has the same problem in it. Your book chooses e to the 2x to be u. I'm asking you to pick u to be sine x just to see that it could work both ways. All right, you can pause the video, work that out, and then check what I have, see if our work is the same. Okay, assuming you are back now, let's pick u to be, I don't want purple, u to be sine of x. That makes du cosine of x dx. dv is e to the 2x dx, so v is going to be e to the 2x divided by 2. And let's, I'm going to actually put that, oh, that's fine. Let me copy this. And let's put it down here. No, not there. No, there. All right, so this is our integral, and we're going to set up with uv, so that's e to the 2x sine of x divided by 2 minus the integral of b du. That'll be minus a half integral of e to the 2x cosine of x dx. Then we're going to do a second substitution. So this was round 1. This is round 2. And just like you saw in class today, we do not want to pick the exponential to be u this time. We want to stick with the trig. So otherwise it'll all cancel out and we won't end up anywhere but right back where we started. Okay, so then dv is e to the 2x dx. V is still e to the 2x over 2. All right, so e to the 2x sine of x divided by 2 minus a half, and then integration by parts on our remaining integral, and that's this stuff is about to get reworked with this substitution. There we go. All right, so uv again is going to be e to the 2x cosine x divided by 2 minus, I was going to switch to plus with the negative sign, e to the 2x sine of x dx. There we go. And then let's see what we can do. We can simplify a few of those things. Move that a little bit this way. Okay, so then we have e to the 2x sine x over 2 minus e to the 2x cosine of x over 4 minus a quarter e to the 2x sine of x dx. And that integral there, this integral is just like our original up to a negative quarter. So we're going to add this whole integral over to the other side, and we're going to get this original integral plus a quarter of our integral. That's going to be 5/4 of the original integral. So let's write 5/4 of the original integral equals the e to the 2x sine of x over 2 minus e to the 2x cosine of x over 4. Yep. And then we need to multiply both sides by 4/5 or divide by 5/4. And when we do that, we multiply the left side by 4/5 and then the right side by 4/5. This first fraction will get multiplied by 4/5. The second fraction will get multiplied by 4/5, and we'll end up with our original integral equals 2, let's see, 2/5 e to the 2x sine of x minus 1/5 e to the 2x cosine of x plus the constant. There's our antiderivative. All right, again, that's using the circular integration by parts. It would have worked out just fine if you'd picked u to be the e to the 2x instead of the trig. But again, it uses 2 rounds of integration by parts. With both rounds, you want to stick with the same classification of pick for u. Here we use trig and trig versus exponential and exponential. If you had switched in the middle of the rounds from round 1 to 2, then everything would cancel out. You'd end up right back where you were. All right, let's move on. Okay, so we're looking at trig integrals, specifically where the integrand is a product of, we're only going to look at sines and cosines today. Friday will be tangents and secants. And these integrals are going to organize into 2 categories. Category 1, category 2, type 1. It's an integrand where at least one odd power of sine or cosine shows up. So here are 4 examples. We got cosine cubed x, sine squared x. Here's the odd power. So it's type 1. Here's an integral with an odd power, type 1. In this case, both functions are odd powers, power 3, power 1, odd powers. Here they're both odd and the same power. So all of these 4 fit into type 1. And then type 2 integrands, there are no odd powers present. They're all even powers. So say cosine squared x or sine squared x. Here it's a power to the 4, power 2, or maybe they're both the same power. It doesn't matter if they're the same power or not, as long as they're all even powers, no odd powers. And let's handle type 1 first, and then we'll come back and handle type 2 because you work on them differently. Type 1, you're going to choose the function with the odd power. You're going to factor off a single power. That'll leave a remaining even power. And then you'll rewrite that function with Pythagorean identity, cosine squared x plus sine squared x equals 1. Then it'll lead to u sub. Then you'll integrate. So here's what we mean. So find your odd power. In this case, the odd power is the 3. Let's see. The 3. So we're going to take a single cosine off of that odd power. That'll leave us with an even powered cosine. Then we're going to take our even powered cosine right here, and we're going to rewrite it with the Pythagorean identity. So that would be 1 minus sine squared, 1 minus sine squared x. And we still have the sine squared x off to the side. And then take a look at what we just did. So if we picked on the odd power and took off a single power of cosine, well, cosine is the derivative of sine. And then look, we took cosine squared and we wrote it in terms of sine. And in doing this, we isolate a single cosine, knowing it's the derivative of sine, and then all the other factors are in terms of sine. This lets us make sine u for a u substitution, and when we differentiate u, we'll replace our cosine. So if we make u equal to sine of x dx, no, u is sine x, so this is our u substitution, then du is cosine of x dx, and then let's start to replace. 1 minus u squared for this sign here. This sign becomes u squared, and then we need to replace cosine of x and dx. Cosine of x dx is a du. There's our u sub replacement. And now to integrate, it's algebra and integration. So we need to distribute the u squared, and now we can do the power rule and replace the u. So power rule is going to be u, what's our u? U is sine. So it's going to be sine cubed over 3, sine cubed x over 3 minus sine to the 4x over 4, no, sine to the 5x over 5 plus c. There's our, there is our antiderivative. Okay, so now I'll let you pause and you try this cosine cubed x. So there's no sine, there's no even anything present, but we have an odd power present. It's cosine cubed. So run through the process. You'll take off a single cosine, rewrite the remaining even with the Pythagorean identity, and use a u sub. Okay, pause, try that out, and then come back. All right, assuming you paused and you came back, if we followed the process, we'd have cosine squared x. Here's our single cosine I factored away. Rewrite cosine squared as 1 minus sine squared with the Pythagorean identity. There's our single cosine of x. If we do a u sub, this is 1 minus u squared, cosine of x dx. All of that becomes du. And then we can integrate like normal. We get u minus u cubed over 3 plus c, put the u back in, and u was sine. It wouldn't work any differently if we had not cosine cubed x, but sine cubed x. Similar situation, we'd just be using a different u substitution. And here we should indicate our u substitution there was u was sine, du is cosine. All right, let's keep going. Here again, we have a type 1 cosine cubed sine, and two options for this. We have an odd power cosine. Let's actually change this. Let's change this to just to have something different. Okay, so 3 powers of sine and a single cosine. Since we already have a single factor cosine, it being the derivative of sine. Actually, I'm going to go back. Yeah, okay. So we could get away with a simple u sub here. We could say u is cosine of x, negative du is sine of x dx. And so this would substitute as u cubed, negative u cubed is du, and we get negative u to the 4 over 4 plus c. That's the quick way. We could also run through with doing the trig work that we've been doing. And not that you would do this, it would be more complicated, but just to show you what would happen if you had cosine cubed x, sine of x dx. We have cosine squared x. Here's our sine x. I'm going to put the remaining single factor of cosine on the end. If we did a u sub, no, we need to rewrite cosine squared in terms of sine. That's 1 minus sine squared x. We have our sine of x there, cosine of x dx, and now do a u substitution. U is sine again, du is cosine of x dx, and what does our integral turn into? 1 minus u squared, u, and then du. And like before, we distribute the u minus u cubed du, integrate, and plug the u back in. U was sine. So we get sine squared x over 2 minus sine to the 4 over sine to the 4x over 4 plus c. And I know it doesn't look the same, but they actually are. Maybe another day I'll take time to work through and give a reason why negative cosine of the 4x over 4 plus c is actually equivalent to sine squared x over 2 minus sine of the 4x over 4. But not that you'd have to show that they're the same. If you work through a u substitution process, you'd be done. This is correct. If you work through trig integral process, this would be correct and you'd stop. Last one, you try and yeah, this last one, you try and then after you've unpaused, come back and check your work. All right, you're back. We end up with cosine cubed, odd power, sine to an odd power. You can pick, again, any function with an odd power to work with, but you only pick one of them. So before we've been picking, let's pick sine this time. So here's cosine cubed x. We'd have a sine squared x and a sine with the single factor we removed. And we have, my daughter's going to use the blow dryer. Just shut the door, Annie. That's good. And then sine squared, that's 1 minus cosine squared x. And then here's our single sine left. Sine being the derivative or related to the derivative of cosine, let u be cosine x. Du is negative sine of x. Okay, so negative du sine of x dx. All right, so we'd have u cubed, 1 minus u squared, du, and all of this is negative. We need to distribute. We're going to get u to the 5 minus u cubed. Take your antiderivative and plug cosine back in. So cosine to the 6, x over 6, cosine to the 4, x over 4 plus c. There's our antiderivative. If you had picked, I factored apart the sine cubed. If you had picked cosine cubed and factored, you're going to get a different looking answer, but it's correct. I say it's correct if you work through the same process. Okay, type 2s. Let's go back. Type 2s, let's see, we have our even powers. We're not going to do any factoring. What we're going to do in the beginning anyways, we're specifically going to write all even powers using these two half angle trig formulas. Notice they're the same up to a sine. Cosine squared x and sine squared x are a half and then times 1 plus or minus cosine 2x. The plus version goes with cosine. The negative version goes with sine. I tend to remember that because, let's see, the plus version I put with the cosine here and the cosine here because they match. The negative version because cosine and sine do not match. Okay, let's scroll down here to number 5. Okay, cosine squared. If we write it with the half angle formula, that's 1/2 1 plus cosine 2x dx. You can either bring the 2 in, maybe let's do that. 1/2 plus cosine 2x over 2. And we can integrate each term. So this would be 1/2 x plus, sine 2x divided by 4 plus c. Remember, we've been doing those types of problems lately where, we might integrate cosine 2x and the outer function anti-differentiates to itself. You repeat the inner function, you divide by the constant derivative of the inner function, which would be 2, but there's already a 2, so now you multiply and get 4. Let's do this one, and then I'll give you the last one to handle. This next one's going to be more complicated because the power is higher. We have 4, not like down here we have 2 and 2. So your first step is to rewrite all functions with their even powers using the half angle formulas. So cosine to the 4, that's a cosine squared x squared, and we have a sine squared x. So now the cosine squared x becomes 1/2 1 plus cosine 2x. And we're squaring all of that. The sine squared x becomes 1/2 1 minus cosine 2x. And there we go. And then dx. And then this is just algebraically really, it's, I don't know. It works out, but it's a pain. So let's deal, we're going to have to deal with the exponent too. If we bring that in, it'll change the half to a quarter. And then we're going to have 1 plus cosine 2x times another one times 1/2 1 minus cosine 2x. And I guess it's not bad. You just got to be, I don't know, clever in how you work this. Just how you decide what to multiply. So 1/4 and 1/2, that's 1/8. I'm bringing it outside. Then I'm not going to multiply these two yet. I'm going to keep one of them. There we go. Then times 1 plus cosine 2x times 1 minus cosine 2x. And there's a lot of foiling going on there, but I'm going to pick on these two because they're conjugates of each other. So when we multiply those, 1 plus cosine 2x, there we are in front. When we multiply these two gray ones with FOIL, FOIL, the inner two pieces are going to cancel. So you could check that if you want. So we just need to multiply 1 and 1 and get 1. It'll be minus, and then the product of the last two pieces will be cosine squared of 2x dx. Now we have this to deal with. That's an 8 and what happens? Let's see. Okay, so if we FOIL, I believe we'd have 1 from the first two. The outer two, that would be minus cosine squared of 2x. Then the inner two plus cosine 2x. And then minus cosine cubed of 2x. And then let's talk about where we're at. 1/8. Okay, so what can we anti-differentiate? So, and what can we use an identity for? We could go ahead and anti-differentiate 1, and then anti-differentiate this with a half-angle formula, or we could replace all of this with a half-angle formula, and let's do that. That will switch to sine squared of 2x with the Pythagorean identity, plus cosine of 2x minus cosine cubed 2x. That's going to require a type 1 integral. All right, so sine squared 2x, use the half-angle formula. 1/2 1 minus cosine of, okay, here we have, that's extra tricky. So it'd be, let's scroll back to our half-angle formulas. Let's see. Yeah, okay, so look at your sine squared of x or cosine squared of x. Whatever the input is, x, it gets doubled in the input on the right side. So that same thing happens here, but look, our input was a 2x, so the 2x is going to get doubled. It's going to be double the current angle. There we go, plus I'm just going to keep writing cosine 2x for a minute, and I'm going to, let's see, dx minus an eighth integral cosine cubed 2x dx. All right, so an eighth out front, and then what can we do here? So we'd have 1/2 minus cosine of 4x divided by 2 plus cosine of 2x minus the eighth. Let's take cosine cubed 2x, cosine 2x dx. All right, let's handle the stuff in front. 1/2, let's see. 1/2 anti-differentiates to a half x minus, we'd have sine of 4x divided by 4 and times the 2 is 8 plus, no, minus sine 2x divided by 2 minus, let's see, all of that. Yep. Oh, we need a dx in there somewhere. Let's move that over a little bit. This one, that dx is in there. Okay, minus an eighth. If we did our u substitution here, let's make this would be a 2. And okay, the cosine squared 2x becomes 1 minus sine squared 2x cosine 2x dx. And we're going to make u equal to sine of 2x. Then du is, let's see, we want half of du is cosine 2x dx. All right. I'm going to distribute the eighth. We have x over 16 minus sine 4x over 64 minus sine 2x over 16 minus an eighth, and then we're integrating 1 minus u squared du, and then times a half. So let's make it a 16th. Yeah. Okay, so x over 16 minus sine 4x over 64 minus sine 2x over 16 minus a 16th. Our antiderivative is u minus u cubed over 2, and u was sine 2x. Plus a c, and if we distribute here on the end, then that 16 is going to go with sine 2x, but that 16 is also going to change our negative to a plus there, and this to a 48. And can we combine any of these? We can combine the middle two, these two. So I think we're looking at x over 16 minus sine 4x over 64 minus sine 2x over 16. No, minus an eighth now. because they're 2/16. So 1/8 plus sine cubed 2x over 48 plus constant. That seems mildly ridiculous, but I think that's it. And just to look at that real quick. Yeah, so I wrote cosine to the 4, cosine squared x squared. That's our cosine to the 4. Sine squared, half angle, 1/2 cosine 2x, all that's still squared, half 1 minus cosine 2x. We need to square here, so a half becomes a quarter. We have 2 of these, and then still a half, 1 minus cosine 2x. Yep, put the half with the 4th, made an 1/8. Have all 3 factors here. I foiled here, 1 plus cosine 2x, 1 minus cosine squared 2x. Then you have to foil again. We foiled here. We ended up with the 1 minus cosine squared 2x plus cosine 2x minus cosine cubed 2x. I think this is working out, yeah. And then 1 minus cosine squared with the Pythagorean. We can anti-differentiate that in a minute. This one's going to be a type 1 on its own. And, you know, I'm going to check later, but I think that's correct. Unless I made a sign mistake or something. And yeah, you can see that's just absolutely ridiculous. Usually I'll tell you, well, any powers higher than 2 are unpleasant. If this had been cosine to the 4 sine 4, it's even more difficult. So take a moment, work on cosine squared, sine squared, pause the recording and come right back. Okay, if you've unpaused, I think maybe you found out this is an easier one to deal with. A half 1 minus cosine 2x dx. Take out the half, that's going to be a quarter. And we're looking then at 1 plus cosine 2x, 1 minus cosine 2x dx. And when you FOIL those, again, FOIL, the O and the I are going to cancel. Hi, welcome home. I'm recording real quick. When you FOIL there, it's 1 and minus cosine squared 2x. Let's, rather than integrate each of those, let's use the Pythagorean identity and make it sine squared of 2x. So again, all of this became this. And then sine squared 2x, that has a half angle identity. It would be 4x this time. Let's combine the half and the 4. Half and the 4th, that gives us an 1/8 outside. 1 minus cosine of 4x. And now dx. And now we can anti-differentiate each piece. The 1 anti-differentiates the x. We have sine of 4x over 4 plus c, so it's x over 8 whole minus sine 4x over 32. Definitely quicker, easier to handle, but that's how that works out. All right. Thanks for tagging along. You take care. If you have any questions, let me know, and see you all on Friday.